This video is on similar figures and scale. Similar figures are figures that have the exact same shape but are different sizes. And we use the tilde, this squiggly line, to indicate that two things are similar to each other. Here we have two triangles, triangle ABC and DEF, and we would say that they are similar to each other. They are the same shape, but they are clearly different sizes. Here we have two similar squares. In similar squares, they have corresponding sides and corresponding angles. It means the sides and angles are in the same place in each figure. So, for example, A and E are corresponding angles because they're in the same place. Likewise, B and F are corresponding angles because they're in the same place. D and H G and C. These are all corresponding angles because they're all in the same place. Sides can be corresponding as well. Here we have side AB. That corresponds with side EF because they're on the same side of the rectangle. Therefore, side DC corresponds with side HG. Side BC corresponds with side FG. And finally, side AD would correspond with EH. So those are corresponding sides and corresponding angles. The important thing to know about corresponding sides is they're going to hold that ratio. That's what's going to make these two figures similar, is they're going to have a ratio. So AD is to EH as AB is to EF, and so on and so forth. As we've already discussed, these two figures are similar. So what do I mean by corresponding sides being proportional? Well, so that means they have to hold a ratio. So let's look at this example. Let's say AD is 2 and EH is 4. And then let's say that AB is 3 and that EF is 6. So for these to be proportional, for these two figures to be similar, these sides have to be proportional. So what has to be true? AD, or 2, over EH, or 4, has to be equal to AB, 3, over EF, 6. And let's see if that holds true. 2 over 4 is 1/2. 3 over 6 is also 1/2. So yeah, this checks out. These are proportional figures because their sides hold this same ratio. And that would be true for all of these sides as we went forward. Okay, so DC would be proportional to HG, BC would be proportional to FG, so on and so forth. That's how you know that these are similar figures. Their sides are proportional. Let's look at the application of similarity, and this comes right out of your book. This is something I like to talk about every year. It's this idea of indirect measurement, and you can do this with people and trees, or smaller trees and bigger trees, and it works based on this principle. The idea is the sun, on any other time other than right directly overhead, because then we don't have these shadows to work with, but the sun is striking a building and let's say a person at the same angle, and the person and the building are both 90 degrees to the ground. So they form these sort of similar triangles, right? These two right triangles, one much larger than the other. And if we know that the person is 5 feet tall and their shadow is about 3 feet long, right? We can put a meter stick down and measure that. And then we measure the building shadow and we find that that's 15 feet. If we recognize that these two triangles are in fact similar, then whatever the ratio is 3 to 15 must also hold 5 to the height of the building. So to go from 3 to 15, or 3/15, we multiply by 5. So to go to 5 to whatever, we must also multiply by 5. So if we do it as a cross product, we can see 3x equals 15 times 5, 3x equals 75, x equals 25, which again is 5 times 5. So in this example, we could say that the height of the building, based on the height of the person, is 25 feet tall. And this would hold for anything that's standing 90 degrees to the ground, and is being measured at the exact same time of day. Scale. Scale drawing or model is a similar representation, right? It's the same shape of an actual object or place. A map is a very prevalent example of a scale drawing, okay? You've seen scale hearts before or other scales in science when you're looking at a representation of something that's not the actual size. Globes are scale models of the Earth. Okay. The scale is the ratio of the measurements in the scale drawing or model to the actual place or object. So that's the scale or scale factor, we sometimes call that. It's how we figure out how far we're traveling on a map given a number, a distance in inches, centimeters, so on and so forth.